Okay, let me tell you about this GC7860D. This is the operation interface. This is a pressure gauge. Then this is the actual detection display temperature. This is set temperature. This is the protective temperature. This is the temperature of the pressure gauge. One is the temperature of the injection box. One is the temperature of the detector. Give an example. We can set its temperature here. Like 200. You can follow our own detection method. Detection conditions to set. For example, 80 you set here. For example, 230 you set here. After setting it up, click this to start. Start temperature control. Okay, just wait for it to control. After its temperature reaches our set value. So let me show you. This gas, including GC area gas, including gas and auxiliary gas. Just hydrogen air. This is hydrogen. Hydrogen regulator to 4.4 revolutions per minute. Our air regulator valve 6.4 revolutions per minute. Normally you don't need to touch it. Just follow our settings directly. This is this purge. This is a tail blow. Is 3.0 revolutions per minute. This is the shunt regulating valve. This is the carrier gas regulator. If you use a headspace sampler, we use the carrier gas from the headspace. No need. This weather, the carrier gas can be set to 0. It can be adjusted to 0.6. Then this next. Adjust carries air. Can be adjusted to 4.4 revolutions per minute. The pressure here is 0.50.05 MPa. So this is pressurization. So this is 0.1, 12 megapascals. This pressurized carrier gas must be larger than this one here. You can according to our needs. A diversion. Then reduce the shunt. The pressure gauge will rise. If you increase the shunt, it will fall. This is also based on our needs. To adjust it, also reduce its diversion. Then increase its pressure. Okay, let's take a look at this in reverse. This is our set point. This is the measured temperature. Now is our measured temperature. It has reached a temperature of the set value. Then according to what we need. The required detection conditions are: you can set it to multiply by heating. Set temperature. Set time to minutes. So let's say we set the heating rate to 5 degrees per minute. Finally reach a temperature of 200 degrees. Hold it for 10 minutes. This is a setting for multiplying by temperature. EPC controlled. We don't need to worry about this, because we are using valve control now. This is the relay. Don't worry about it. This is detector. You don't need to type this stopwatch. Then after reaching our set point, click on this ignition NG. How do you know if it's on fire? First, take a look at this det detector. Is there a signal? There is a signal generated, so it's on fire. One more. Just take this bright green wrench. Can it be above this detector? Check to see if there is any water vapor generated. What if there is water vapor generated? Proof that it was also on fire. Okay, let's talk about headspace sampling. I told you about that earlier. Here is this pressurized regulator. This is the carrier gas regulating valve. Must be larger than this carrier gas regulator. Its stress. Then this is also according to our needs. To adjust his carrier airflow. Carrier gas turns to the left and increases. Turn right to decrease. This screen here. This is the furnace temperature in the first row. The back one is the pipeline temperature. And down below is the valve body temperature. This can be set according to our needs. This is pressurized. This is heating time. This is the pressurization time. This is sample time. EIA time. Injection time. Then purge time. This soap time. What about this soap time? Must be bigger than it. The actual time of this test, including cool down, if you program the temperature, including a cooling time for it. This time must be greater than the sum of all time. Okay. This is the set. The setting is set as this including this. Pipe temperature. Furnace temperature, this pipe temperature. This is the valve body temperature. Here is a setting for a pressurization time. This is here is the setting with added time. 30 minutes. It is based on a request for our testing samples. One of his detection conditions to set is this pressurization time. 10 seconds for this sample time. Sampling time 10 seconds. Then ring the screen for 5 seconds. Injection time 10 seconds. Is this the purge? 1 minute or 2 minutes. You can set it up here. This is a subtime, so the subtime must have just been told to you. Must be greater than this, the sum of all this time. It includes this a sub. After the temperature cools down here. What about that initial temperature? This time. Then it rotates and rotates this sample plate here. Turn the sample plate hum. Then you can follow this serial number at this time. Join our sample questions. Okay, this is a rotating sample plate. In our empty gold sample bottle. This is already configured. This headspace, this sample bottle must be pressed tightly. Then we can use this serial number to put in the top controls in turn. The sample can be paused for a while or 123,456. Then you can follow our sample. Its serial number. Put in the top control bottle. OK. And then click Reset to reset. After everything is ready, including this temperature, everything was in place. Click Run. Then it's heating time. Just move forward with the time we set. After 30 minutes, it will automatically hydrostatic pressure. Headspace. Let me add one more thing here. Is this the sample taste? A setting. Then you can set the number of digits to the number of digits here. You say number 1 to number 4. Make sure this is okay. Save. Save and use it. This is our, sample area. For example, you are number 1. To 16, then directly enter 16 points to save use. Okay. This is its time. Then just wait for it to, After reaching our time, it will run automatically. Okay, next, let's explain the use of this software. Is this the icon of our software? Double-click the software. Enter the program. Go into the program and tell everyone about it. This one here is newly built. Open here. Open the PUDA file, for example. Is this for preservation? This is a print. This can be adjusted. Whole size. Up and down. This, left and right, up and down. Then this is this the URL? You don't need to change this after it opens. Will it automatically connect? Connection is, what if a line of code like this appeared below? The connection is successful. Is this a setting? If set, does this correspond to that screen? Does it include anti-control? A device to reverse control this temperature. Set it up. This sets the temperature. This sets it up. This corresponds to the temperature of the meter. Tank temperature. And the temperature of this detector. This is set and this is read. Okay. Is this multiplied by warming? If we don't need it, it can be removed. This corresponds to this meteorological soup. This screen corresponds to events. This sampler. This is the sampler. This is the detector. This is the internet. This is the version. This is the beginning of the analysis. This is the beginning of the analysis. Don't worry about that. Is this setting its name? This is stop collecting. Pop up the dialog box. This is automatic. Auto-save. Is this for preservation? Curves and component tables. Is that a quote? Curve component table. Is this a manual point? Integral manual integral. This is the one below our interface. Is this a channel? A choice of channels. A choice of channels. Usually choose a channel. This is its stop time. We have to test the sample according to the actual situation. It sets it at this air outlet time. This stop time. Is this the delivery value? Minus 2,500. Don't move this. This is the most, This is recognizing the wind. Lowest wind height. This is the lowest, minimum wind area. This is the area. It's an infinity. Set it to infinity. This is a setting for the x-axis. X-axis 0 minus 30. This is the y-axis. A setting of the abscissa x-axis. Vertical y-axis. One of its settings. This is set according to one of our actual needs. Click if you want 0 minus 50. Then the 0-50s axis is the target. -10 to 50 -10 -50 It will have a display. From -10 to 100, so that's -10 to 100. This is to create the component list. Create an interface for the component table. I'm going to show you a little bit of that. This outlet area. An interface for generating results. Okay. What about this interface? Is this one of his areas? An option for area and seal height. Generally, this area is selected. Here is a quantitative method. Include this internal standard method. External standard method includes normalization method, area normalization method, and this correction normalization method. There is also an external standard normalization method, and this index method. These quantitative methods. Okay. This is the current inventory. I'll show you later. How do you create this component list? And this is to calculate its existency. Computational survivability. And he built that curve. Create a work in GC-IRV. Okay, after everything is ready. After the temperature reaches our set value. Okay. Click this. Start collecting. Just let him go to the baseline. Take the baseline. After the baseline is stable, you can inject. Okay. This adds 30 minutes. 30 minutes after arrival. Click Reset. Okay, click and run. It automatically mutes. Okay, he pressurized. Sample for 10 seconds. Then the EIA will take 5 seconds. Then static pressure. Static pressure for 10 seconds. Okay, then blow back for a minute. It will automatically. Headspace will automatically start this workstation interface. This is the baseline capture interface. Okay, after the samples are in, it will give a wind, then automatically stop. For example, you set to 14.5 minutes. It stops automatically. Then I can save it to. You need to save it in this interface. Then the concentration is 10, 20, 40 of 60, 80 of 100. This is a standard sample. How do you deal with the wind? Just open the M10. Is this the sample we made? Here is a tool to deal with the wind. Click OK. Click this hand. Then this 7.1 for 6-7 minutes is our target wind. Can all other winds be deleted? This is delete wind. What is the most used? Pan forward. Pull back. This is a delete regional wind. Is this air pressure positive? That's divisive winds. So in that case, is there a logo on it? How does it function? A function of the hairdryer. Then we can delete the wind. Put this mess. We delete what we don't need. If you go deep into the regional wind, tap, tap, tap the wind, start to finish. Okay. Is this processing wind? Our target wind remains. Click Save. Okay. Then press 2. The same hand. Click. Click this to delete the area seal. Click. Good to save. The fourth one. Delete area seal. Okay. Save. The fifth one. This is half of what has been dealt with. Okay, so this is processing wind. After dealing with the wind, how do I create a component list? In this component list, this line, this column. So when we first turned on our concentration, from low concentration to high concentration, concentration time point component table. Click on the check mark. Click to enter the component name. Like, yeah. The sample is A, for example. Then enter its concentration. Take it 10 input hum. After losing, click Clear. Clear an archive. Clear the file. OK, and then click the Day Table Archive again. Save OK. Then open the second one. Same. Click on this component name and you don't have to lose it. Direct input concentration. This is 20. OK. Then click on the current table archive to add 40. Open the component list. Click 40. Current table archive. 60 of. Down. Input brightness 60. Single arrow clear file. 80.1 under. Single arrow clear file. Stop and count. Okay, here's a work in GC IRV. Click. Let's see if we saved these 12. 40. If not, can you rejoin? Or delete and do it again? It's a calibration curve. Click Calibration. Click More. This place. Multi-point. This is multi-point calibration. Click Calibration. It will form a curve. This is its linear equation. The linear equation y is equal to case plus b. And this is it, this correlation coefficient. OK, then click OK. And then this is, save. This is the other save one by one. Click. Save it to a place where you can find it. I save it in this standard sample. Name can be entered. Save it. How do you apply the canonical curve? For example, so this is one of the prototypes that we did. How to get it out of concentration. If the concentration is so high, we can use this place is to quote his component list. Calibration curve. This place. Is that a quote? Click and then open the tutorial curve you just made. Click Open. OK. Click on the battery calculation. It will automatically give the result. That is the concentration. This is its component name. It will automatically give the result. OK. OK, how do I change his concentration? Check it out here. And there's an assistant. Is there a correction concentration unit here? This place can modify its concentration. Concentration unit. According to your own needs. Set up. OK. OK. OK end. Print report. How to print this PUDU report. In the file, open with a print preview. This is one is the systematic evaluation report. This is a quantitative report. Sure. See if this is what we need. You can do it at this place. Can you set it up? Set that report header. Does the end of the report include that name? You can set it up here. After setting, this place can be set up. Okay, make sure. Then just print it directly. Print here. Okay.